So MV Pro here at the Lucid Vision Labs stand at Photonics West. I'm here with Alexis Teissie, who's going to take us around their booth and just showcase some of their products they've got on show here for us. So Alexis.
Hi. So here we have our newest short-wave infrared camera, the Atlas 10 Square. It's using the Sony IMX992 5.2 megapixel sensor, the one equipped with the tech cooling device. We now have a full range of Sony Square camera. We are one of the few manufacturers that will support all Sony sensors, both in the cooled and uncooled version. That will cover from their first generation 0.3 and 1.3 megapixel with 5 micron pixels, and their second generation 3.2 and 5.2 megapixel with 3.45 micron pixels. And those are available in the cooled or uncooled version. The cooled version is using the Atlas platform. We needed a larger platform to just accommodate the power requirement for the cooling device. And because we have a larger platform anyway, and because the sensors are requiring faster speed, we adapted it on our 10 gigabit platform. So it's a Gigi 3.0 camera using remote DMA, remote direct memory access, that can get you 5.3 megapixel at around 120 frames per second. Here we have a simple demo showing with different wavelengths, 1550 or 1300, typical short-wave infrared targets, different foreign material detection, a Canadian build that has some safety feature. You can see that some of the ink is reflective and some is not. Here it's water detection. Some of those containers are filled with water, so are empty. They look very different to the naked eye. To using SWIR, they can be easily discerned. One key part we've done for this design is the tech device is basically adjusted to a set point, which it will try to maintain the sensor temperature to the set point.
Okay.
Out of the box, it's 20 degrees Celsius, but that's user controllable. If a user wants to run the device cooler, they can then adapt that device. They will have to take care potentially of their mechanical integration to make sure the camera is integrated and connected to a heat dissipating surface. But you can then control the tech device and the set point for the sensor. Especially if you use with longer exposure time, that's when you benefit the most from the cooling capability of the sensor.
Okay, so just picking up on that point then, as you said, it comes out 20 degrees out of the box, but are you seeing a lot of that, across actually this whole setup with the cooling and all that, from the customization or the standardization? Actually, people are just saying, just give me the thing, I want to sort of take it off the shelf and plug it in, or actually, can you do this, can you tweak that for me?
So that's especially for SWIR, because those are on the pricer side of the product. There will be, let's say, a lot of pre-sales question and qualification that gets addressed. That's also why we have both cooled and uncooled version. The uncooled version is smaller, slightly cheaper, obviously, but it's really depending on the application. If the customer can run with shorter exposure time or bring in more lights, they may get by with an uncooled version. That really depends on the use cases. If you're in the semiconductor industry and you can have external light, or if you're in the biomedical industry and you're constrained by whatever light you can have and you need to run longer exposure time, that may be a decision point for using the cooled or the uncooled version. We do provide a full EMBA 1288 characterization of the camera and the image sensor performance, so that's available for each and every product, and obviously on the SWIR cameras from our website.
And so just to sort of finish with the SWIR camera here and the 10 gig E, are people sort of this is not flying off the shelves, but going pretty quickly, rather than we'll come to some of the other ones later that are perhaps a bit newer, and therefore people are a little bit more just taking one or two, testing the water. So this is a bit of bread and butter.
SWIR imaging is well understood for many years. It was up until very recently constrained to the lab and the R&D offices because of the price of it, the cost of it. Sony, being one of the mainstream sensor manufacturer, helped a lot, making that more affordable. It's not yet cheap, but it's way more affordable than it was a couple of years ago. So we are seeing a lot more inline inspection coming in. We have customers that have a machine, they start providing that as an option to their customer. So the machine is based on visible imaging, but they have the option of having SWIR imaging for additional inspection or processing. There's a price point where this option becomes the mainstream.
Yep.
We are seeing that trend, let's say, picking up steam. Yeah.
Yes, yeah, it's something we've definitely noticed is that people are getting more out of the lab, and as price comes down, people are getting it more deployed and more useful. Brilliant. Okay.
So Atlas 25 camera series, we just started production for the first model in December last year. So it's a 25 Gigi 3.0 RDMA camera. So what's RDMA? Remote direct memory access. The Gigi standard initially was based on UDP and was really optimized for low latency, uncompressed data transfer, which works very fine for reasonable interface speed. Once you get to the 10 Gigi and over, that becomes quite taxing on the host CPU to just decode the packets. We do have a range of 10 Gigi cameras that have been on the market for many years, and we could make them reliable, but let's say more care was needed in the actual, let's say, system design to make sure that you can adapt to those corner cases where sometimes the CPU might get overloaded, especially.
So there's that sort of cost buy-off,
yes.
So we can have this, but
what Lucid has done, and we've been at the forefront of RDMA adoption into the Gigi standard. So we were first mover, came with our proof of concept. It was never our intention to keep that as a proprietary technology. So we work with the Gigi standard group hosted by the A3 to make that part of the standard. So it's been adopted where the latest draft has been published. It should very soon to an official release. For us, it's a firmware update. Our 10 Gigi camera to adapt RDMA was a simple firmware update, and every new 10 and 25 Gigi products are from the get-go Gigi 3.0 compliance. So for that design, it's actually maybe easier today to design a 25 Gigi optical camera than it is to do a 10 Gigi copper camera, just because of the ecosystem behind it. 25 Gigi and up is used in every data center and, let's say, high-performance computing cluster worldwide. We made the decision to, one key differentiation we did for that product was we built in the optical transceiver. When you use optical 25 Gigi and up, you typically rely on an SFP module, which will get the optical fiber and convert it, transceive it to electrical signal. We build that function inside the camera, which make for a smaller, more cost-effective, more power-efficient design, and overall a more reliable design. That's one thing less that can go wrong. So here we plug the LC connector directly, which gives us a very compact camera. It's essentially the same size as our original 10 Gig camera. It's a drop-in replacement for our customer. And passive cooling, extended operating temperature from -20 to 50 degrees, and shock and vibration resistant design. There's no active fan or any moving parts, which makes, like, for, let's say, much easier integration into typical industrial environments.
And so, because as you just touched on there, it's a sort of a drop-in from the 10 Gigi. Are people, open and sort of sitting there going, "Yep, do you know what? I'll have the 25 now," or are people still a little bit like, "It's new, it's it's a bit different, so actually we need to."
It's been the strategy from Lucid from early on. So Lucid will turn 9 years old this year. To focus on the gigabit Ethernet interface, the Gigi Vision, because it provides a clear upgrade path for our customers. And supported by the sensor vendor, Sony has same sensor at various speeds. And we see that we had customers using our 1 Gigi camera that graduated to 2.5 Gigi, and same with our 10 Gigi customer, that the same sensor we use, the IMX 530 series, it's the same sensor. So all the optical system, all the imaging performance, all of that is unchanged. We just can run faster. So for us, it's really our strategy is to offer an upgrade path for our customer to go together with them to scale up to those higher speeds.
And so, because from your perspective, it's on the roadmap, it's a firmware update predominantly. You're able to get it out of the lab and out of the testing bed pretty quickly.
Because all the ecosystem is there. A network card for 25 Gigi is available broadly because it's not a machine vision specific solution. It's just general networking solution. Our network card is around $200 US for 2 ports, 25 Gigi. And so all that parts, all the rest of the ecosystem is there, it's in place. There's no, let's say, trialing or proving about that. It's really taking those technologies. So RDMA comes from RoKey V2 protocol, which is something, a standard Ethernet protocol. Applying it to a camera is the new thing, but that's the only new thing. The rest of the ecosystem is in place, so we expect to see quite rapid adoption of that.
Yeah, perfect. Okay, so that's the 25, and then we'll try and jump in here. So yes, I'll be quite excited by the Whirlpool and the live action demo.
The event-based camera that's using Prophecy, so sensor, Sony sensor designed together with Prophecy. That has been one of the, let's say, leader of this event-based sensor development. We have had this camera on the market for since last year.
Okay.
It's seeing plenty of interest because it's a very unique, let's say, offering or paradigm. It's a frameless sensor. There's no concept of frame or shutter. It's just each pixel has a custom design that will monitor the illumination continuously, and if the illumination changes over the threshold, it will generate an event asynchronously. Each pixel can asynchronously generate events that give you the equivalent of a very high frame rate camera in a small and cost-effective solution, but more the pixel themselves will sense a change in illumination at both very high and very dark, very high and very low illumination values, which gives for a very wide dynamic range camera, and we see that a ton of interest. It's still new technology, so that one, the adoption, ton of interest. It's in hundreds and hundreds of R&D labs right now. To go from the lab to the full-scale production, we are seeing the first, let's say, the first industrial design, the first industrial application. It's still too early to comment on telling you that this is the one application
that it's going to be used. But I suppose looking at it and here, because like you said, it's not shutter speed reliant or anything like that, because it's pixel based and event based. The sort of opportunity, I guess, for it is pretty broad, because here we're looking at a Whirlpool, but I know on the demonstration it's got people walking around, it's got cars. Actually, that real world, because that's again one of the big topics we're seeing here at Photonics and across the machine vision space more generally, is people taking that out of lab into real world solutions. And so like you say, okay, it's new, people are testing with it, but actually it's got that opportunity.
That's what we offer as Lucid. Our know-how is to build solution ready for the industrial world. So to make that camera onto a gigabit interface was quite an undertaking. Like, those sensors are available with kind of more an evaluation kits, an evaluation. So even if they are packaged in a camera, they are not, let's say, in our view and to many of our customers, let's say, ready for industrial deployments. Here it's integrated in our Triton 2.5 gigi IP67 house platform. So that's what we offer as a camera vendor, as an industrial camera vendor, is to get you from the proof of concept to the actual industrial world.
Perfect. Well, I mean, that's been fantastic as ever coming to see Lucid. So thank you for your time, Alexis.
Thank you very much.
Thank you.
Thanks.